Welcome to repeated integration by parts. So the general idea here is sometimes when we perform integration by parts, the integral of v du component also requires integration by parts. And so we have to perform integration by parts multiple times in one part. So for example, let's go ahead and evaluate the indefinite integral, which is the integral of x squared times sine of 2x dx. So we have a product that x squared will simplify as we differentiate. So let's take our u to be x squared and our dv to be sine of 2x. You can write the dx or skip it however you like. On the left-hand side, we'll go ahead and differentiate. The derivative of x squared is 2x. Integrating on the right-hand side, sine integrates to a negative cosine. That 2x inside will result in us having a negative 1/2 cosine of 2x. As you get used to some of your most basic u substitutions, you will remember your formulas for them. Anytime we have a linear factor inside our function as our u, we just divide by that essentially slope. Right? So if we have our setup here for integration by parts, we do the product of the first diagonal, then we subtract the integral of the product of the bottom. So this becomes the integral of x squared times sine of 2x dx is equal to an x squared times a negative 1/2 cosine of 2x minus the integral of 2x times a negative 1/2 cosine of 2x dx. So we are looking at negative 1/2 x squared cosine of 2x plus the integral of x cosine of 2x dx. This integral of x cosine of 2x dx is once again a product for which u substitution does not work. So we will run integration by parts once again. We will set u to be x, dv will be that cosine of 2x dx. Again, we differentiate on the left. We integrate on the right. So x goes to 1. Cosine of 2x, integral of cosine is a positive sign. Then of course we have our 2x inside, and to undo that chain rule, we have to do 1/2 out front. Again, we do our positive product on that first diagonal. We subtract the integral of the product of the second diagonal. So we wind up getting that we have our integral of x squared sine of 2x dx is equal to, we originally had a negative 1/2 x squared cosine of 2x. Then we are adding on, we now have x times 1/2 sine of 2x. And then we are subtracting off the integral of 1 times 1/2 sine of 2x dx. That is an integral we can figure out without integration by parts. I'm going to give myself just a little bit more space. From here, we have, therefore, that we are looking at negative 1/2 x squared cosine of 2x plus 1/2 x sine of 2x. And then integral of sine is a negative cosine. So this becomes minus 1/2 times, we'll have a negative, we have a cosine of 2x, and then of course u sub, or undoing that chain rule, we should have a 1/2 out front as well. So integral of sine of 2x is a negative 1/2 cosine of 2x. So that minus the integral of 1/2 sine of 2x dx becomes a negative 1/2 times negative 1/2 cosine of 2x. And then we have our plus c. So all in all, we are looking at a negative 1/2 x squared cosine of 2x plus 1/2 x sine of 2x plus 1/4 cosine of 2x plus c. So this is running integration by parts twice. Now let's go ahead and do another example where we evaluate the indefinite integral, which is the integral of x cubed e to the 4x dx. So in this case, we'll start off by setting our u to be x cubed, our dv to be e to the 4x. If we differentiate on the left and integrate on the right, x cubed will go to 3x squared when we take the derivative. E to the 4x, we would have an e to the 4x, but then of course to counteract the chain rule, we should have a 1/4 out front. We do the positive product on that first diagonal and subtract the integral of the product of that bottom row. So we have the integral of x cubed e to the 4x dx is equal to x cubed times 1/4 e to the 4x minus the integral of 3x squared times 1/4 e to the 4x dx. That of course simplifies to 1/4 x cubed e to the 4x minus 3/4 times the integral of x squared e to the 4x dx. That integral of x squared e to the 4x dx, we'll go ahead and take x squared as our u, e to the 4x as our dv. Technically it's e to the 4x dx. We differentiate on the left. We integrate on the right. X squared derivative goes to 2x. Integral of e to the 4x. Again, we have an e to the 4x, but to counteract that chain rule, we have a times 1/4 out front. So our integral of x cubed e to the 4x dx, we now have, we do product on the first diagonal, subtract integral of the product on the bottom row. We keep our 1/4 x cubed e to the 4x that we already had. We subtract off 3/4 of our new integral. Our new integral, we have an x squared times 1/4 e to the 4x. We subtract off 2x. Sorry, we subtract off the integral of 2x times 1/4 e to the 4x dx. Simplifying this, we are looking at 1/4 times x cubed e to the 4x minus 3/16 times x squared e to the 4x. Then we have plus 3/8 times the integral of x e to the 4x dx. Again, 3/4 times 2 would be 6/4 times a fourth simplifies to 3/8. At this point, we will run one more set of integration by parts. That integral of x e to the 4th dx, we will set our u as x, our dv as e to the 4x. We take, again, technically there's a dx on the end of that. Take the derivative along the left side, integrate along the right. We wind up with 1 and a 1/4 e to the 4x. We do the positive product on that first diagonal. We subtract off the integral of the product of the bottom row. And our integral of x cubed e to the 4x dx. We are now looking at 1/4 x cubed e to the 4x minus 3/16 x squared e to the 4x plus 3/8 times, we will have an x times 1/4 e to the 4x minus an integral of 1 times 1/4 e to the 4x dx. This now simplifies to 1/4 x cubed e to the 4x minus 3/16 x squared e to the 4x plus 3/32 x e to the 4x minus 3/32 times the integral of e to the 4x dx. And so this becomes 1/4 x cubed e to the 4x minus 3/16 x squared e to the 4x plus 3/32 x e to the 4x. Of course, the integral of e to the 4x is 1/4 e to the 4x. So this becomes a minus 3/128 e to the 4x. We're finally done with our indefinite integral, which is what we were asked for. So now we just need our plus c. So again, this is for performing multiple iterations of integration by parts to find an integral. In the next video, we will learn what is called rapid repeated integration by parts, which allows us to do this much faster with some shorthand notation using the tabular format for